Hi everyone. So, after having the first video on the basics of electrolysis, we're going to study what electrodes are. Because students are often confused in this idea. So, let's recall it that there's an anode, also known as the positive electrode, and the cathode is the negative electrode. Anode obviously is connected to the positive terminal of the battery. So, the positive terminal is the one which is the longer line while we generally draw it. So it is connected to the positive terminal while cathode is connected to the negative terminal of the battery, which is the smaller or the shorter line. Whenever you see a battery, the longer line represents the positive terminal, so that is the anode, and the shorter line represents the negative terminal, which is the cathode. When we talk about ions, the anions are the negatively charged ions. So they are always attracted to the anode. That's why the names are similar, anode and anion. So anions are negatively charged ions move towards anode, and cations are the positively charged ions which move towards the cathode. That's why similar names. When the anions go to the anode, oxidation occurs at the anode. So anions are already negatively charged, they lose electrons, while cations are positively charged and reduction happens on cathode. So reduction happens for the cations at the cathode. Anions are generally made by non-metals. So when oxidation happens at the anode, obviously the product is also a non-metal, like chlorine, bromine, oxygen. These are the non-metal produced on the anode, and on the cathode metal deposit happens, except for hydrogen, because hydrogen is the only ion which is non-metal in nature but positive. So apart from hydrogen, metals happen on cathode. There's a thing called inert electrode which do not take part in the electrochemical redox reaction. So last time when we were having the electrolysis of the sodium chloride, yes, we were talking about the idea that the electrode was inert, so it did not participate in the redox. Their mass remains the same because they are not participating in the reaction. For example, graphite and platinum are inert electrodes, so there is no change in the mass of graphite. Yeah, obviously metal deposits can happen, but it does not increase the mass of the graphite itself. Let's talk about the qualities of inert electrodes. Number one, they have to be conductors. You can't have insulator material as an electrode. Next thing, they should have a higher melting and boiling point, because if you are having a molten electrolyte like molten sodium chloride or molten lead bromide, your electrode should stay solid, right? Otherwise it would melt. So it stays solid even if the electrolyte is molten and heated. So they need to have a higher melting point, like graphite has a very high melting point, and that's a good thing. Third thing is going to be they have to have inert nature. For example, graphite and platinum are very less reactive compared to the electrolytes, so they do not participate in reaction, like graphite, which is pure carbon, and platinum, which is a very inert metal because it's very lower in the reactivity series. When we talk about more electrolysis, let's have a look at the electrolysis of dilute sulfuric acid. It's unique in a way because it's not a single compound, it's rather a solution. Imagine you have electrolytic cell with dilute sulfuric acid in it. You have two graphite electrodes which are connected with a copper wire with a battery. So I have a battery, the cathode is connected to the negative terminal, anode with the positive. In dilute sulfuric acid, there are sulfate ions and there are hydrogen ions. So there are hydrogen ions, there are sulfate ions, and since it's water, the OH minus ions and H plus ions are also present because of the water molecules. All the OH minus and all the sulfate minus will go towards the anode because of the electrostatic attractions, and over there the oxidation of OH minus will happen. So OH minus and sulfate minus will both go to the anode because they are both negative in nature. They are both going to go to the anode. So we use the word of migration of ions. OH minus and sulfate migrate to the anode. Over there, the oxidation will happen, we know this. Towards the cathode, the hydrogen ions will go from the sulfuric acid, And obviously water hydrogen ions are the same thing, so they go towards the cathode. So all the hydrogen ions go towards the cathode. There is no other kind of the cation, so it's only the hydrogen ions which are going to go towards the cathode, again due to the electrostatic attractions. Now at the anode, the OH minus and sulfate minus are both going, but the oxidation will happen for only one of these, and that is OH minus. So OH minus ions will oxidize themselves, release 2 water molecules, lose electrons, and make 1 oxygen molecule. So you will see the bubbles of colorless gas, which is actually the bubbles of oxygen gas on the anode. Sulfate minus ions will migrate although, but they won't be discharged. However, OH minus, hydroxide minus ions will be discharged, and you will see bubbles of colorless gas, which is oxygen gas, evolving at the anode. That is your product. At the cathode, you will also see bubbles of colorless gas, because this time the hydrogen plus ions, the H plus ions, are discharged. At cathode, always reduction happens. So at the cathode, H plus ions are reducing themselves to become hydrogen gas. H plus ions will gain electrons to become hydrogen atom, but you know hydrogen always exists as a diatomic molecule. So you're going to see 2 hydrogen ions gaining electrons and becoming hydrogen molecule. So this time the bubbles of colorless gas belong to hydrogen gas. So at anode, oxygen is evolved, at cathode, reduction. Let's recall that our electrolyte was dilute sulfuric acid, which means sulfuric acid along with water. The ions were H plus ions from the dilute sulfuric acid and from the water. Sulfate ions were there from the sulfuric acid, and because it was water added, water always has H plus ions and OH minus ions of its own. At anode, sulfate ions and hydroxide ions both migrated, because they both are negative in nature, they both have electrostatic attractions with the anode, so they are both migrating. But OH minus will discharge themselves, they will oxidize themselves, they will lose electrons, and they become oxygen gas. However, sulfate ions are not easily discharged, they remain in the solution. They are not discharged at all. At the cathode, there's only hydrogen ions, so it's only one possibility. So the hydrogen ions will go towards the cathode, because hydrogen ions are positive in nature. Cathode, as we know, is negative in nature. So hydrogen ions will discharge, they will gain electrons, they will do the reduction, and they will form hydrogen gas, which is our product. Bubbles of colorless gas will be received on both the electrodes. Now there's one thing remaining, and that we'll see the diagram very soon, but we know that the products are oxygen gas and hydrogen gas. The overall remaining solution has some ions remaining in it, because not all the ions are discharged. Hydrogen ions, some of it will remain in the solution, and sulfate ions are remaining in the solution. So they form sulfuric acid, because these 2 ions are essentially sulfuric acid. So the sulfuric acid concentration increases. If we look at the diagram in this way, where we have 2 test tubes inverted, and there's a cathode over there on the right hand side of the diagram, and there is anode on the left hand side of the diagram, because you know the positive terminal and the negative terminal. So the left side electrode is the anode, which is positive electrode, and the right side one is the cathode. You will see bubbles of colorless gas on both sides, but cathode will have more bubbles. Why? Because hydrogen is produced in more amount. When hydrogen is reduced, hydrogen ions are reduced, I should say, hydrogen gas is evolved, and when hydroxide ions are oxidized, oxygen gas is evolved. But notice that in the oxidation of hydroxide there are 4 electrons, but the reduction of hydrogen ions has only 2 electrons. So equalizing these 2 equations will involve that 4 hydrogen ions will gain 4 electrons and produce 2 hydrogen molecules, because to equalize the number of electrons. So actually 2 moles of hydrogen gas will be produced and only 1 mole of oxygen gas. So you will collect more hydrogen and half the amount of oxygen. However, the concentration of sulfuric acid will keep on increasing. So remember, whenever there is 1:2 mole ratio of gases, it is very likely to be sulfuric acid, because hydrogen is produced doubled as compared to the amount of oxygen produced. I hope it's clear to us, and in the coming video we'll talk more about the aqueous solution electrolysis. Stay tuned, guys.